So I work on Alzheimer's disease. It's a disease that I usually don't have to introduce to anyone because almost anyone has been affected in some way, whether it's been grandparents or some distant relatives. Almost everyone knows somebody who has been affected, and we're very likely to be affected later on in our life, either ourselves as a patient or as somebody who takes care of somebody who's had it. So in the human body, all cells are dependent on waste disposal systems because there are proteins that are folded the wrong way, or there are organelles, like little parts of the cells, that get damaged. So the cell needs to get rid of them in order to not get sick from them. So for most cells in the body, that is relatively important, but they also divide and you get new cells. So they eventually die and new cells replace them. So that's okay. But in the brain, most of the cells there are actually born very early in life. Once these cells are made, they stay in the body and they age. So whatever happens in there, like all the misfolded proteins, everything that aggregates stays in there unless this waste disposal system works efficiently. We're trying to reverse some of the damage that has been done in the Alzheimer's brain, or even better, prevent it in the first place. So we're trying to go in early. We think a good way of doing this is switching on this waste disposal system by using a master regulator. It seems like the Alzheimer's brain is trying to do that to a certain extent itself anyway, but it seems to fail. So we're trying to enhance that and give it that extra push that it might need to get rid of it.